another PO, and you know the POs are super important. That's because these terms you are going to be learning in PO7, supplementary and complementary. You've learned them before. I know this. You've had these terms before, but we're going to start to apply them, use them into solving for angles and things like that. So raise your hand. Who can remind us all? What is a complementary, or what are, I should say, complementary angles? Andrea. Correct.
Aren't they two angles with the same measure?
Ooh, no, those would be congruent angles. They can have the same measure. It's possible that's not their definition. Nathan?
They complement each other.
Very good. No. Two angles that sum to 90 degrees. Okay, two angles that sum to 90 degrees. I sometimes joke with kids, like if you can add to 90, 180, and 360, geometry is going to be easy because a lot of recurring numbers, we saw this with right angles, now complementary angles. 90 is a big part of it. And complementary angles are two angles that sum to be 90 degrees. Complementary angles do not have to be adjacent. You can have complementary angles like this, where you've got 60 degrees and 30 degrees here. Okay, or they can be separated. You can have a 10-degree angle here and an 80-degree angle here. They are still considered complementary angles. They can be adjacent. They don't have to be. They can be congruent if they're both 45. Okay, but there are two angles that sum to 90. Andrea.
Oh, I know supplementary.
What are supplementary angles?
Two angles that sum to 180.
Yes, two angles that sum to 180 degrees.
Is the next one 360?
No. Two angles that sum to 180 degrees, and like complementary angles, they do not have to be adjacent. A linear pair, like we've talked about before, okay, they are also supplementary angles. If you've got 130 degrees here, 50 degrees here, because they sum to 180, they are supplementary. They also are a linear pair because they make a line. However, they don't have to be 80 degrees and 100 degrees. Okay, they don't have to be adjacent angles. Any two angles that sum to be 180. Yes, Nathan.
Are there any angles that are 0?
You cannot have a 0-degree angle.
Why not?
I mean, I suppose you could relate it to slope and say it's elevated at 0 degrees if it's a flat surface. But if you're measuring the angle of a polygon, which is the context that we're using angles in, you can't have a 0-degree angle. It's got to have some sort of measurement to be the angle of a polygon. And again, I'm going to limit this to angles of a polygon. That's what we're building to. And so my answer right now is no. Andrea.
Oh, I have a third one.
The third one?
Yeah.
Yes.
Two angles that share common vertex inside but have no common.
Too wordy. Adjacent angle. But yes, you are correct. Adjacent angles. Two angles that share a side. Two angles that share a side. An example of adjacent angles, we've talked about this before. These are adjacent angles, right? They share that side. You've got your 60-degree angle here and your 30-degree angle here together, right? That blue-red side is shared. And same thing here. These would be adjacent angles also, right? Two angles that share a side. So, in the diagram below, the measure of angle 2 is 90 degrees. Write that in there. And the measure of angle 3 is 30 degrees. Give an example of complementary angles, supplementary angles, vertical angles, and a linear pair. Raise your hand. What would a pair of complementary angles be? Corbin.
3 and 4.
Why would 3 and 4 be complementary?
Because they add to the 90.
How do you know that the measure of angle 4 is 60?
Because measure angle 2 is 90 and 3 and 4 make it. Why that's 2 and 4.
Okay, so this line right here, if you look at the right side of it, okay, angles 2, 3, and 4. We know that the measure of those three angles has to be 180. Do those three angles make a linear pair? No, because there are 3 of them versus 2. Linear pair, 2. Okay. Are 2, 3, and 4 supplementary?
Yes.
No, because there are 3 angles, not 2. However, because the 3 angles make a line, we know that their sum together is 180, making this one 60. Okay. These terms, these special terms here, only refer to 2 angles. That's true for adjacent, true for supplementary, complementary, linear pair. They all have the word 2 in the definition for a reason. Okay? It doesn't mean that 3 angles can't add to be 180. They're just nothing special, right? But Cormac used that logic to conclude that angle 4 has to be 60, because if we already have 90 and 30, that's 120. That leaves 60 degrees for angle 4 to complete this line of 180. So he said that complementary angles are angles 3 and 4. Any others? Andrea?
1 and 6.
Why are 1 and 6?
Because, well, 1 is vertical to 4, which makes it 60, and 6 is vertical to 3, and which makes it 30.
Sure.
30 to 60.
Yeah, so we can actually get on to vertical angles here also. Angle 1 and angle 4 share a vertex. They're opposite each other. Therefore, they are congruent. So we know that angle 1 has to be 60 degrees as well. So angle 1 and angle 4, we can put that under the vertical section. She's also saying that 3 and 6 are vertical angles, right? 3 and 6 share a vertex. They're opposite each other. They are congruent. And so angle 6 is 30 degrees as well. Okay? Hold on. So 1 and 4, angle 3 and angle 6. We can add another one now to our complementary section. Angles 1 and 6 are complementary as well. Okay? Let's get to supplementary. Any angles that are supplementary? Nick?
1, 6, and 5.
So supplementary angles, again, this definition matters. It must only be 2. It can only be 2. Nick, do you have an idea?
It's gotta be.
Finn?
This one actually fits under 2 categories, and it's 2 and 5.
Correct.
Fits under supplementary.
2 and 5 are vertical angles as well, making 5 90, making 2 and 5 a pair of supplementary angles. And we can add 2 and 5 into our vertical angles as well if you would like. Okay? Any other pairs of supplementary angles? Nathan?
No.
Thank you. You are correct. Colin? Very well. Okay. Linear pair. What is an example of a linear pair? Nathan?
2 and 4. No, 2, 3, 4. No. There's none. There's 0.
Okay, for your first answer, your second answer, and for your third answer, there aren't any. Why are there no linear pairs here? Why are there no linear pairs, Fuldinsky?
Because any possibilities that can add up to 180 aren't 2 pairs. So
They don't make a line, right? The only options that we have for 2 angles to sum to 180 are angles 2 and 5 here. Okay? The other part of a linear pair is that those 2 angles make a line, which angles 2 and 5 do not. Right? Now, could we create like an angle 7 by combining 3 and 4 to make this whole angle 7 and say that 2 and 7 are a linear pair? We could. We're not. Okay? But we would have that option if we wanted to really extend this.
Then you can also say 2 and 5 are angles.
Right.
Ooh.
Okay? Questions on complementary, supplementary, vertical angles, inaction, linear pairs, Colin?
Does that mean that angle 1 and angle 3 are also complementary?
Angle 1 and angle 3 would be complementary as well.
And the
Yes.
same for 4 and 6?
And same for what?
4 and 6.
4 and 6, yes. You can also add those into our list. Okay? Good. All right. Again, like we saw in the CO6, we are looking at relationships here.
Oh, I remember this.
Similar thing here. Similar thing here. What relationship, what equation, right? Because when I say relationship, I'm talking about equation here in the algebraic sense. What equation can we set up for the first one that will allow us to solve for x? I think, do I have you solve for x? Is that what the directions are?
We did this.
Find the measure of g, yeah.
We did this already.
Then the last
We
one.
did this one?
We did this. We did all of these.
We already did these. We already did these. They're in the book.
Yeah, we did this in CO6.
Oh, I gave you this for homework?
Yeah. You gave us this for homework.
We
can keep
Okay.
it like this.
Okay. Well then, for a quick review, what equation can we won't solve it. What equation can we set up for that first one? Jocelyn.
18x minus 9 plus 4x plus 13 equals 180.
How do you get 13? Oh yeah. shoot, that's
Basically,
supposed to be like-
the sum of the two angles there have to add up to 180. They are linear pair. They are supplementary. So 18x minus 9, our first angle, plus 4x plus 13, our second angle, have to add up to be 180. How about the second one? Oh, I remember this. Now we talked about two different ways you do it. We're on this. Paul.
6x plus 4x equals 90.
6x plus 4x equals 90. We talked about you could write 6x plus 4x plus 90 equals 180, but your first step of moving that 90 over the other side brings you right back to that relationship anyway. And then for the last one, yes, we talked about how you can't, you have to set up an equation with the x angles first. And so once you do that, 14x minus 100 plus x plus 5 equals 180. Then you can solve for y and go about your day there. So your assignment for tomorrow is going to be the review section.
Yes.
What is the midpoint formula? Draw and label vertical angles. Draw and label a linear pair. What is the distance formula? Draw and label an angle bisector, and then draw and label ray AB. From your textbook, formerly Paul, but I stole it back.
Are you joking?
Come on, Phil, please.
On page 40,
40.
I would like you to do 34 through 44.
44.
Questions.
It's a show.
Only 11 questions.
Only.
That's
That's 10. That's 11. That's 10.
Gotta
sing it.
I'll let you figure it out.
34,
Go ahead.
35, 36,
Oh, there must be
37,
an
38,
extra.
39,
40,
41, 42, 43, 44.
If you're counting 34 as one of them and 44 as one of them, there are 11 questions. Their difference is 10, but there are 11 questions. Apologies may be verbally or written out. Send to room 260, St. Vincent de Paul.
No thanks. My PO7.
You almost
Sorry,
almost.
Schultz.
You have
All right, homework for tomorrow, the review and the book page. That's how you math.
Forget to like and subscribe.
And send your apologies.